large this thing is. And that'll be it for the unit. And then we'll take the test Tuesday. Before we get into dilations, I just want to go over a vocabulary term called invariant points. All right, invariant points. You guys have actually probably experienced invariant points through the course of this unit. You just never knew they were invariant. Have you ever done a problem in here for me, whether it's in your notes in your homework, where you've done a transformation and one of the points doesn't move? It just stays right where it is, doesn't move at all. That's called an invariant point. All right, so an invariant point, points that do not move after a transformation. Transformation. All right, so you do the transformation that's asked, and you know what? This point just stayed right where I plotted it. Didn't move anywhere. That's an invariant point. So instead of just giving you a definition here, let's actually put this to use. This is the first and last time you'll be able to do this, because you know how I feel about this. If you want to do a quick sketch of this quadrilateral, because I did not put a graph on there, so if you want to do a quick sketch, this pains me that I'm doing it as well. But the coordinates aren't that big, so we can graph them. This is painful right now for me. 1, 2 is point A. 0, -3 is point B. 2, -3, point C. 3, 0, D. Good. There it is. First thing I'm looking for, I'll call on somebody here. Give me something where point B remains invariant, meaning tell me to do a transformation where point B is right where you graphed it. It will not change and move anywhere. Now remember, we only have 3 options in here. We got reflections, rotations, and translations, you could tell me. Right? Reflections, rotations, translations. Give me something, be detailed about it, where if I perform it on point B is not moving anywhere. And let's take the funny business out of here too. Can I do a rotation of 360? Yeah, you can. Good job. How about a translation of 0, 0? Yeah, good job. Funny kid. All right, I want something else though, a little more clever than that, please. All right, so think about it. You can talk about it in your groups right now. Give me something, all right, something detailed where point B is going to stay right where it is. Right where it is. Let's go dig deep. Dig deep. Find. I think you guys can think about it pretty quickly. Give me something. One of these 3 up here we've talked about where point B not going to move. Not going to move. All right, ready to roll? What do you got for me here? Ones. Makai, what do you got back there? Hey, there we go. We got a winner. Reflect over the y-axis. Yeah, points A, D, and C will move, but if I tried to move point B, it's going to stay right on the y-axis. Good job. We're going to get challenged here. I want something else. Give me something else I could do, and I'll give you the first hint. It's also another reflection through a line. Where is that line I could reflect over other than the y-axis? All right, come on. Dig deep. Where else can I reflect? Let's go, Simon.
X equals 0.
X equals 0. Okay, that's the y-axis. I don't want another name for it. I want a new line. This kid. Bailey, you think you got it? Come on.
Reflection over y equals -3.
Y equals -3 because that's a horizontal line, right? Y equals horizontal line. Great job. X equals 0. All right, one more. How about point D being invariant now? Give me something I could do to point D being invariant, meaning you do this, D's not going anywhere. D's not going anywhere after I do this. Two, Bailey, back to, actually, you know what? You gave me that great one here. I'll go on to somebody else here. 8. Ooh, Char, let's go. Whoa, gave me the tough one right away. Good. Reflection over the vertical line. x equals 3 right here. Yeah, D's not going anywhere. Or, you're lucky she took the hard one there. Where else could I go here? 1, 0. How long has it been, Henry? Go ahead. Thank you, sir. I reflect over the x-axis. Perfect. All right, so those are invariant points. Points that don't move. All right, wanted to just highlight that before we get into the meat of today's notes. Questions on the invariant. And then finally, here it is. Dilations. Now, why do I leave this to the end of the unit? Remember what these three have in common? These all three are called what? Rigid motions. Good. Is a dilation a rigid motion? No, why not? Changes the size, right? Changes the size. So they don't remain congruent with the dilation. And here's probably from what? Your middle school days? You guys think of dilations as probably this. Oh, well, I'll take this figure. You tell me to dilate it. And what happens? It probably gets bigger, right? Well, it could also get smaller, yeah. But I want to actually show you guys today why it gets bigger and why it gets smaller. Because think, if I had point A and I'm going to do a dilation, does the point actually get physically bigger? No. No, it doesn't. All right, so I want to show you why today, when you do a dilation, your figure does get bigger or it gets smaller. All right, so first thing with the dilation, there are two items you need to be aware of. Two. Number one is the center, where we are dilating from. All right, that's the first thing you need to be aware of. Where are we dilating from? It's called the center of dilation. The second thing, which is probably the most important thing, is my scale factor. All right, my scale factor. So take a look up here. My first example right here. Everyone sees my pre-image, ABC, and then did I get bigger or smaller? It got bigger, right? Here's why it got bigger. My scale factor was 2. Does everybody see the center of dilation here? Right now, point A is a certain distance away from that center. All right, I'm not going to do distance formula or anything, but everyone see, look at it. Point A is a certain distance away. The scale factor was what again? 2. That means I'm doubling my distance away from that center. So do you see why A prime got further away? Not only did it get further away, it doubled its distance away from the center. Everyone see that? Same thing happened to B and C. It doubled its distance away. So does everyone now see why the figure is getting larger? All right, because the points are moving further away, twice as far away. All right. Now over here, what's my scale factor here now? 1/2. Notice what's happening to the points now. Here was A, here's A prime. Are they getting further away? No, they're getting what? Closer now. All right, half the distance closer. So the scale factor is important. It'll tell you if your points are getting further away or if they're getting closer to the origin. So let's fill in this box right here. A scale factor bigger than 1. All right, if the scale factor is bigger than 1, that's when an enlargement happens. That's when the points get further away from the center. A scale factor, now so this might be a little nuts and I'll explain it to you. If the scale factor is between 0 and 1, my figure is going to get smaller. That's going to be a reduction. And I know some of you are like, well, what if it is 1? It stays right where it is. Doesn't go anywhere. All right, get the same figure back. And anybody else know what other type I'm missing here? We're not going to deal with it, but it is possible. A negative scale factor? What happens if I have a negative scale factor? That is possible, but we're not going to deal with it. So you just got to worry about bigger than 1, it gets further away. Between 0 and 1, it gets closer to the center. Are you ready to actually dilate now? All right, let's actually dilate. And you guys aren't ready to dilate a figure yet, so we're going to stick with a single point J, which I have already graphed for you. All right. Let's actually write down what J is, because that's going to be important at the end of our discussion here. What's point J here? 3, 2? All right, point J is 3, 2. I'll get back to that after we're done with parts A, B, and C. All right, let's get nuts now. Part A, dilate point J. Where's my center? Where's my center? Origin, 0, 0. So that's my center of dilation, 0, 0. And we're going to do it by a scale factor of 2. First question, is J going to get closer to the origin or further away? Further away, because the scale factor is bigger than 1. Now, how do I determine where it is? Because remember, we're saying this distance right here is about to double it. All right, so J prime should be somewhere over in here. All right, how do I find out where it is? We're going to use slope. All right, so everyone start at the center, 0, 0. Tell me, I'm going to call on somebody here, up and over how many units do I need to go to get to J? Up and over how many units from 0, 0 do I need to go from J to get to J? 2. Bailey, up and over how many?
2 over 3.
Okay, up 2 over 3. Double it. Ready? Up 2 over 3. One more time. Up 2 over 1, 2, 3. Here's J prime. I just doubled that distance away from the origin. And let's write it down too. J prime, 6, 4. Everyone see? J prime got further away. Not only did it get further away, doubled its distance. Oh, you went up 2 over 3. All right, I'll do it again. Up 2 over 3. All right, let's go 1/2 now. Scale factor of 1/2. J prime going to get closer or further away from the origin? Closer, 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 right? Bailey, back to you again. What do we do to get from the origin to J?
Up 2 over 3.
So if I went up 2 over 3, I want to cut that in half and now go up 1 over 1.5, right? Cut it in half. Up 2 over 3. Instead, cut it in half. We're going to go up 1 over 1.5. There's J prime. And what is that coordinate there? What do we got? 1/2, 1.5, comma, 1. All right, one more. What about a dilation of 3 now? So triple your distance. All right. Well, let's go back here, right? We went up 2 over 3, up 2 over 3. That was doubling it. So do it one more time. Up 2 over 1, 2, 3. J prime. And that is 9, 6. So is everyone seeing how powerful that scale factor is? All right, now it's you and your group's time. I want a shortcut. Maybe I don't feel comfortable doing slope. Is there a shortcut that I could get to all those answers quicker? And the answer is yes. Here's what I want you to do in your group. I want you to look at point J, which was 3, 2. I told you we'll get back to that. Point J of 3, 2. And then I want you to look at the scale factor of each of them. And look at the point we ended up at. Is there a relationship or pattern that I can use to go a little quicker instead of going up and over, cutting in half, doubling it, tripling it? Is there a pattern? So look, we always started with 3, 2. I want you to look at the scale factor of all the 3 and the point we ended up on. Is there a shortcut we can make? Talk about it in your group. Go ahead, give you a minute. No, that was a quick discussion. Any group think they come up with something? No? Good job. Yep. Anything? Group? Oh, here we go. First of all, you better tell me the right thing. Second, hopefully what this group's going to tell me, and I got to make sure I emphasize this, this only works if we dilate around the origin. If we dilate around another random point on the graph, this little trick doesn't work. It's only when we dilate around the origin. What are you guys going to say? Everyone agree? I could just multiply my coordinates by whatever the scale factor is. And that is true only if I dilate around what? The origin. Because we're going to do more problems where we don't dilate around the origin, and I can't use this shortcut. All right, so here's the shortcut. Again, I'm emphasizing the center of dilation has to be the origin to use this. You multiply x and y. That's, jeez, one job. There we go. X and y coordinates by your scale factor. Again, this is just a shortcut. Does it mean you have to use it? No. If you guys are comfortable doing the slope that we just did before, keep using that. All right, let's go. Let's roll now. Now we're going to go a little quicker here. All right, what happens if I don't dilate around the origin? Well, can't use the shortcut, but I can still use slope. Dilation of point J again, which is 3, 2, stayed the same. Scale factor of 2, but notice my center of dilation now is 7, 1. So now find 7, 1. Find 7, 1. Now that's the center. So I can't use the multiply shortcut now. But I could still use slope. First question here, if we're going to dilate by 2, is J going to get closer or further away from 7, 1 that I have up there? Further away. It's going to double its distance. So we always start at the center of dilation, 7, 1. Somebody tell me up and over how many to get to point J. Up and over how many? Bailey, again, you're on fire today. Let's go. Up 1 over 4. We're going to double it. Do it again. Up 1 over 1, 2, 3, 4. There's J prime. J prime should always be on the same side as the center. Shouldn't cross it. All right, we're not crossing it. Negative 1, 3. All right, I'm going to walk around, see you do part B and part C. Let's do it. You know you go up 1 over 1, 2, 3, 4. Cut it in half and triple it. And let's see what your points are. If you want to compare, talk within your group about it, that's fine. Make sure you start counting from the center. Do not cross the center on the other side. All your points should be on the same side. Yep, good job. Good. Keep it going. Woo. All right, you ready to go here, kids? Scale factor of 1/2. Scale factor of 1/2. Where do you end up at? Tess.
5, 1.
Oh, look at you. 5, 1.5. Good work. 5, 1.5. Questions? All right, how about J prime with the dilation of 3 now? Scale factor of 3. Tess, we already heard from you. I don't want to hear from you again. Lauren, here we go. What do you got over there, Lauren? Negative 5, 4. Good work. Anybody else? All right. I don't have to do much talking anymore here. So now I think you guys are ready to dilate actual figures now. We've done points, and let's do figures. First, before you get crazy, where am I dilating? Where's the center here? Origin. So you can use my multiply shortcut. If you want, you don't have to. You can use slope as well. So let's see where your triangle and your 1, 2, 3, 4 pentagon end up here after each scale factor 2 and 1/2. If you want to take the coordinates and multiply by 2 and 1/2, you can here. You can do the multiply shortcut, or you can just use the slope. Remember, you're going from the origin here. So if you guys are using slope, please count using the origin. Whew. Scale factor of 2, that thing should be getting bigger. Scale factor of 1/2 should be getting smaller. Good. I'm seeing both methods being used here. I'm seeing you guys multiply by the scale factor, which is great. And I see some of you guys using slope and cutting it in half and doubling it. Perfect. Good job. Whatever you're comfortable with, guys. Whatever you're comfortable with. Head, finish up. Okay. We also have to be comfortable if the scale factor, if the center is not the origin. We got to be comfortable doing those, and that's what this last one is here. Okay, so if you turn to the last one. So we're going to dilate by 2. So in our minds right now, we're saying, all right, the points are going to get further away. Further away from what? Our center, which is point D. Is point D the origin? All right, so I can't use my multiply shortcut here. Everyone good? You cannot use the multiply shortcut. I'm not dilating around the origin. So I need to make sure I use my slope here and double it. Start from point D. Always start at the center of dilation and go up and over how many, and now double it. All right, double it. So all your points should be getting further away from A, B, and C. Let's see it. All your points should be getting further away. I cannot multiply by 2. All right, I'm not at the origin. So everyone's got to start at point D, up and over how many, or down and over how many to get to point A, and now double that. Same direction. Let's see what you got. And you should have a triangle that is larger because the scale factor is bigger than 1. And just make sure we look good up here. Points are where they should be. I got a little note here for you guys. You guys have been assigned number 30 tonight. One of the 5 problems I assigned tonight is number 30, and you need the distance formula for it. So quick, so we just don't skip it because we don't remember the distance formula. Okay, little distance formula. That's for number 30 tonight. Number 30, you're going to need it.